Hello.
Hi, everyone.
Hi, everyone. Joe and Igor here from MarsTalk. Thank you so much for joining us today for the Perseverance landing. We're super excited to have everybody on. We've got a lot of exciting things planned for you. We've got a lot of really great people that we're going to be talking to. Yeah, I'm super excited. Igor, how you feeling?
I feel great, actually. I'm really excited about this, and of course, Perseverance landing. That is just gonna be awesome. Yeah. So everybody, thanks for joining in. Thanks for taking the time, and thanks for following us. We at MarsTalk really appreciate it, and we're actually looking forward to being your host tonight.
Perfect. All right, let me get everything all going. So we're also going to have the NASA live feed up, so you'll be able to see along with us what NASA is doing. If anything really exciting pops up and NASA wants to announce something or talk about something going on with Perseverance, we might just jump right over to them. Otherwise, we're just going to kind of talk through the whole mission, the rover itself. We'll go through some of the instruments that they'll be using on Mars. And we'll just kind of talk you through it. You know, there's a lot to unpack with the Perseverance rover, and I'm really excited to dive into it. This is a huge moment for Mars missions, not only because landing anything on Mars is a monumental feat, but also because you're landing something on Mars, also the size of an SUV, that's going to be looking for signs of life. You know, Curiosity was unique in the sense that it was looking for habitability on Mars. So was Mars at one point habitable? Did it have the conditions? Did it have the chemistry, the atmosphere that was conducive for life starting on Mars? So that was, can life happen? Now we're looking at, well, is there life on Mars? That's really exciting. Also, there's a helicopter on Mars. I know, Igor, that's your favorite part. So
yeah, that's my favorite part. Exactly. That is the Ingenuity helicopter, which is like this is the first time in history that we are gonna have a helicopter on another planet.
Yes.
To have powered flight on another planet, that is just amazing. And really, it's great to have something like that. It's really a great technological advancement, and it's going to be great if everything works. It's going to be super fantastic. The Perseverance doesn't only have, of course, the Ingenuity helicopter. Of course, it has a lot of instruments on board. Also, it has the MOXIE, which is the little instrument which will transform Martian air into oxygen, separating CO2, into one oxygen molecule and a CO molecule. And
Igor, I'm just going to pause you really quickly because I can see how excited you're getting.
Of course.
And I know there's a lot of time back. I'm going to bring on Robert Zubrin, Dr. Robert Zubrin, to give us a little bit about the Perseverance rover and kind of talk about the Mars Society's role in it. And so we're extremely appreciative to have Dr. Zubrin join us on the call today. Let me see, I just brought him on. Dr. Zubrin. Hello, great, there you are. Hi, Dr. Zubrin, how you doing?
Hello, Dr. Zubrin.
Doing okay. How are you?
Great. Very excited. A lot of energy, a lot of emotions, but feeling good, feeling really good.
Right.
So yeah, thank you again for joining us. We wanted to bring you on, Dr. Zubrin, to hear your thoughts on the Perseverance rover. How are you feeling? This is a big day, not only for Martian missions, but also for the future of putting people on Mars. There are several experiments that are going to have a huge impact on that. So can you speak to that? I mean, how are you feeling?
Yeah, sure. And also, if I might, have a few words about not just the Perseverance rover, but the other missions that have happened.
Please, yeah.
This same month. Okay, well, first of all, Perseverance is a great mission. showing the value of using the same kind of rover twice. And I think, in fact, we should be banging these things out and sending one to Mars every 2 years. The Mars is a big planet. It's got a lot of places to explore. There's also hundreds of instruments that competed for a chance to get on the Perseverance rover, and only about 5 managed to get on. So there's all kinds of other investigations that could be done in all kinds of other places. And we should not be doing these, once every 8 years. We should be doing these once every 2 years. Now, Perseverance has got powerful instrumentation. In terms of the onboard instruments, I'm particularly interested in the microscope. That is the ability to look for microfossils. A ground rover like this is not as good as a human rockhound for looking for fossils, but at least it's got the tool and it has a chance. And of course, it's going to a place where there was water, where you might have a chance of finding them. Now, of course, the other thing that is extraordinary about Perseverance is the helicopter, Ingenuity. This is going to be great. Now, of course, this is just a little helicopter. This is to helicopters what Sojourner was to rovers. But Sojourner, the size of a toy tank, got followed by Spirit and Opportunity, the size of bicycles, and now by Curiosity and Perseverance, the size of Volkswagens. And if the helicopter works, it's going to increase our Mars exploration capability 1,000-fold. And I mean that literally. That is, the ground rovers can maybe travel a couple of 100 meters in a day. A helicopter could travel hundreds of kilometers in a day.
Right.
Hundreds of kilometers, not hundreds of meters in a day. So that's 1,000 times faster. And furthermore, it's not limited by terrain obstacles. If there's a ravine in the way, it could fly right over it, or it could fly to the bottom of a canyon and land there. And I'm thinking of helicopters, not just this, which is order of a kilogram. I don't know the exact mass of Ingenuity, but I'm talking about something 50, 100 kilogram class, a Spirit and Opportunity class helicopter that could carry around a Sojourner rover and land in various places, let it loose to go sniff at the rocks, and then call it back, grab it, and fly it somewhere else. Okay, this is the way. And furthermore, this kind of robotic vehicle, another thing it could do great is ground penetrating radar. Radar signals, the radar signal return goes as the inverse fourth power of the distance. So a helicopter flying at 100 meters altitude could get literally millions of times the better return than an orbiter at 300 kilometers altitude. And furthermore, it's much more precise because you're getting the data from right there. So if you want to find underground caverns, if you want to find near surface underground water, if you want to find the place where these subsurface glaciers are covered by only inches of dust, use a helicopter for scouting. And then furthermore,
it's going to be so much faster trying to explore. One of the frustrating things I've always found, and understandably so, is that rovers move incrementally slowly on Mars.
Oh yeah. So this is the difference between using a bird or using a snail.
Yes.
100%. And you want to use bird. So I've always been interested in flight vehicles on Mars.
It's also, I think one of the, Ingenuity, I'm excited, obviously, to see Ingenuity take off. I think one of the biggest impacts, though, is going to be the MOXIE experiment.
MOXIE, of course. Okay. Well, as you may have heard, I'm a very strong advocate of making rocket propellant on Mars out of local resources. And MOXIE is the first time that we're actually going to do that on Mars. Many investigators, myself included, have done things like this on Earth, and now we're going to do it on Mars. And of course, the ability to make return propellant on Mars is central to the SpaceX plan. SpaceX plan, like my Mars Direct plan, the mission plan is go directly to the Martian surface, refuel there with local materials, and then fly back directly from there. Don't try to build giant motherships that fly from orbit to orbit and land in little landing craft for visits. Go direct to the surface in the same ship that you flew to Mars in, and fly back either in that or in a comparable ship that you landed first. And that's the kind of thing that was also going to be demonstrated on this mission. Now, the other thing I was going to mention about the helicopter is that this is a form of robot that is a very useful auxiliary to human exploration, for the same reason that we use aerial drones for reconnaissance to support, say, infantry in warfare, because they can fly all over the place and see everything and be used to coordinate the ground operation. The same sort of role could be played by helicopters or other aircraft on Mars to greatly increase the effectiveness of human explorers. Scout out the best routes, scout out the best places to go to, and then send the human explorer there. Get the geologist to the rock, and that is the delivery. And so that's what this is going to demonstrate. Now,
excuse me, Dr. Zubrin, we have a question from the audience.
Sure.
If we may. So Momir is asking, how important is this multinational interest for Mars?
Well, it's very important. And yeah, I wanted to talk about this. Now, there's two other missions. One is the United Arab Emirates. And, you know, and the significance of this more broadly than, okay, making a statement to the Islamic world that Islam should not and need not be hostile to science. It could be part of science. Okay, but to me, it's the more interesting thing. It's a statement to all smaller nations that you don't have to be a superpower to send missions to Mars. I mean, if United Emirates can do it, why can't Mexico do it? Why can't New Zealand do it? Why can't Switzerland do it? Okay, why does everyone have, you know, European nations won't, they have sent things to Mars, but only all together. Right. Holland could send a mission to Mars by itself. Ireland could send a mission to Mars. The UK could certainly send a mission to Mars if the United Arab Emirates could do it. So they don't have to do this thing of, well, we'll only go if we can get a lot of friends to share the work. No, anybody could do this, and they should. And then there's the Chinese. Okay, and this is a remarkable thing. Yeah. You know, the Americans, okay, our first Mars missions were flybys. Then we did orbiters. Then we did landers that did not move. And only then did we do rovers. Okay, the Chinese doing that all on the very first mission. And this mission, as far as I know, was only conceived of about 4 years ago. So in 4 years, they developed a complete Mars mission, including an orbiter and a rover. And this is terrific. Now, you know, now there's a lot of concern that people have that, oh, gee, are we getting into another space race? And could this lead to
I was just conflict? About to ask you about that, actually.
Okay, well, yeah, but here's the thing. Whether or not there is conflict between the West and China depends upon how that relationship is managed on Earth. Okay, and I think it's going to take a lot of care. This is a delicate kind of thing that we're dealing with here. This condition is going to have to be managed. This is a long-term situation. This is how the world's going to be. Okay, but I have to say that I think that inasmuch as space can play a role in that, it will be constructive. And, you know, in the darkest days of the Cold War, the space race was a light in the darkness. I have here my old copy of Time magazine with Yuri Gagarin on the cover. This is from April 1961. And first of all, you'll see, if you look at Gagarin's picture, he's not pictured as a villain. He's pictured as a likable person. This is the cover story, and it's like 8 pages long. But I'd like to read the last paragraph of this very long article. Okay, And it goes as follows. So this is Time. And by the way, Time, of the two major news weeklies, was Newsweek and Time. Newsweek was the liberal one. Time was the conservative one. So these people have no sympathy whatsoever with communism. Okay. Okay. Most scientists around the world think that Major Gagarin and the good ship Vostok have opened a door that will never entirely close. Space exploration may slow down for a while or stop, but the human species is young, and it is the bumptious master of a fruitful planet. More men will always yearn to travel in Major Gagarin's wake and see the blue band around the curve of the Earth. Eventually, perhaps 10, 100, or 1,000 years from now, a great spaceship will carry men far out in the solar system. They will learn whether the moon and the planets have value as real estate. They may tinker with the offensive atmosphere of Venus, perhaps making it suitable for human breathing. They may develop human subtypes that will enjoy Venus as it is. They may learn to live in space itself, cruising the solar system in artificial mobile planets. Human civilization is only 7,000 years old, and countless years lie ahead. But wherever future adventurers travel, whatever they find in the black cold reaches of space, they will always remember the pair that preceded them, the Vostok and Major Yuri Alexeyevich Gagarin. Time magazine, April 61. Okay.
That's beautiful. That was
Okay.
beautiful. Dr. Zubrin,
and yeah, it's incredible. And you know, I myself, I was actually in Leningrad when we landed on the moon, and because when I was a kid, I was a chess player, and the Russians I knew all thought it was great. It's molodets. It's like and attaboy. Sure, they would have been over the moon, literally, if it had been Russians had done it, absolutely. But still, we had excelled in a sport that they appreciated. So it's like the Olympics, and it generates good feelings and good spirit. And yeah, sure, let's have a contest with China, not over the South China Sea, but for honors as to who can do the most discoveries on Mars.
Right. You know, that's one of the things that's great about exploring Mars in space in general, is that it's cooperative in general. You know, they were able to build off of the shoulders of giants. You know, we have extreme cooperation on the International Space Station. I mean, when you take space, it's just a prime example of how people are able to come together.
Well, they can come together, or they can compete,
you know,
like we do at the Olympics. And frankly, the Olympics would not be as interesting if everybody got together and said, okay, we'll give you the high jump and we'll take the longest.
I am just going to quickly, just because I do know that there is currently a Facebook watch party happening right now as well. If everyone, you know, it's on Facebook, it's on the Mars Society's page. Dr. Zubrin, I think you're going to be there as well, answering questions.
I'm going to be there. And
Okay.
I hope that a lot of people who are listening to this will go there. If you're not going to a different watch party, go to one.
Everybody here is going to the Mars Society watch party. We made sure of that.
If you're not going to the Mars Society watch party, then you're missing out.
Okay. Well, that's great to hear.
But feel free to come back after the watch party. We're here talking about everything. Again, thank you so much.
Thank you very much.
All right. My pleasure. Thank you.
Yes.
On to Mars.
Yeah, exactly. All right. So I think obviously great. I think you can feel the excitement that everybody has.
Unfortunately, there were more questions though, but
I know.
has to go. So we only had time for one.
Keep those questions, Igor, just because I did want to quickly bring on Lucinda Offer, the executive director of the Mars Society, just because she's been hugely monumental in helping us out with literally everything that we do here at MarsTalk and getting this whole entire live stream set up. So yeah, without further ado, Lucinda Offer, we would like you for us to come on in and talk a little bit.
My pleasure. Are you kidding me? I'm the lucky one. You guys do all the hard work here, and because this is my day job. Normally, I also work for the Royal Astronomical Society. So hello everyone. From England. I'm in the United Kingdom. I work in London, and I'm very excited to be here. Thank you, Dr. Zubrin, for being with us. He's so wonderful and just inspiring and excited about all of this stuff. And I love the historical aspect of this, which is the Mars Society has been around for 20 years, and we've been, very integral to pushing humans to Mars. And we're waiting for those Martians to land on the planet. But we're getting some really great data from these rovers who are giving us so much information about what it might be like for humans in the future. Are you guys still there? Hello. Did we?
Yep. Sorry, I'm trying to also get the NASA feed up here as well.
Excellent.
While we're talking. It's huge. It's one of those things too where I know that Perseverance is an important mission, but it's also what it stands for. It's not just Perseverance, but it's the fact that there's Mars exploration happening at all. That's something that I think is something that we need to appreciate and love, that we live in this time right now where we have like half a dozen robots that are currently exploring another planet.
Absolutely. And are you kidding me? I mean, the pandemic year, we had 3 launches. Dr. Zubrin mentioned we should do this every 2 years. Well, why don't we do 3 launches every 2 years, or 4 or 5 launches? I mean, that's going to end up with a lot of traffic entering Mars, kind of like we have today, which is really interesting. The more data, the more research that we have, the more that we'll know. And honestly, going to Mars for this mission is learning more about our planet and its evolution. Because we're looking at Mars, or what they're looking at is, 4 billion years ago. What happened on Mars? Why did it stop evolving like Earth? And why is there life on Earth? So lots of really great questions to learn about our own planet from this research that we're doing on Mars.
Right. Igor, if you want to take that. Yeah, I think your mic is muted.
Yeah, it is. Sorry. So Lucinda, hi. Yeah, since a lot of people here who participate in this in our live event, don't maybe know much about the Mars Society. So maybe since you are the executive director, you can just, fill us in on what the Mars Society is.
Absolutely, be happy to. So the Mars Society has been around. I mean, it really originated from graduate students back at the University of Colorado at Boulder back into the late 70s, early 80s. They had these Case for Mars paper conferences because they wanted to send humans to Mars, and they weren't understanding why. America had just gone to the moon, and we had done all this research to learn about things that we can orbit. We could land a craft on Mars from 1976 and the Viking missions. And so next step, it was obvious to them, humans to Mars. So they started the research going with these conferences that later led to the Mars Society in 1989. And we have 2 habitats, one in Utah called the Mars Desert Research Station, and the Flashline Mars Arctic Research Station on Devon Island in the high Arctic. And those have been in operation since 2001, approximately. We've had over 200 crews. And we're a nonprofit organization, international. I help build chapters all over the world, and I'm so proud of our chapters around the world. Right now, everyone's so inspired about, never in my membership of being with the Mars Society since 2002, have I ever had so many emails or phone calls or information and questions about doing things locally in their community to help forward humans to Mars all over the world, China, Africa, just Europe. The UK, we relaunched in 2018. We're now working with Oxford University. It's just huge. So I'm so excited about that. And with you guys, Education and Outreach, we also relaunched last year. And now we have this amazing program that's still evolving. If you'd like to get involved with the Education Outreach team at the Mars Society, just let me know, or contact info@marssociety.org, or contact me directly, lucinda@marssociety.org.
Couldn't have said it better myself.
Yeah, thank you, Lucinda. That was very, very informative.
Anytime, guys.
Yeah, so I've been a part of the Mars Society since 2020, and I have nothing but great things to say about it. And so I encourage everybody also, who wants to do anything Mars related or space related and focus their effort on Mars. Come on, guys, be our guests. Just
It's also a great place to start out. If you're not, so I don't have a background in aerospace or engineering.
Yeah.
I actually liberal arts and graphic design, and so if you have a passion for space and you have a passion for Mars, there's a whole bunch of roles here at the Mars Society for you. Literally 1,000 different things that you could do here. So
That's right. Dr. Zubrin's always said it'll take all skills and talents to get us to Mars. We're going to need everything. We'll start with the great foundation of engineers and scientists, but eventually it'll be just like living here on Earth, and all skills and talents are going to be needed.
Perfect. No, that's awesome. Thank you so much. Lucinda, if you want to stick around, we'd love to kind of have you around too, back when the landing is happening, during the 7 minutes of terror. And then we can all kind of just let out a sigh of relief when it all just kind of, when it happened.
I trust in engineering.
We'll
I trust in
cry
engineering.
together. We'll laugh together. So just be one big happy family.
Hopefully opening up a champagne bottle, not together, obviously, but.
Don't have one, but I have some other alcohol I can use.
That's perfect. No, thank you again, Lucinda. We really appreciate it.
My pleasure.
Okay. Igor, I know we wanted to talk about the search for life on Mars. And I know we wanted to kind of explore everything Percy's doing to look for signs and kind of, store some of those samples and what we're looking for exactly. I know we wanted to bring in Chris. I don't see Chris yet. And so I'm thinking, I see Max. We want to talk about really how difficult it is to put a rover on Mars. We'll start with Max and
sure. Yeah, that would be great.
Bring it in. Great. Okay. So let me introduce this unique individual first. I know he's probably watching, and so hopefully I do him justice. This gentleman is one of the most brilliant people I know. He's an engineer, been an engineer for a very long time, knows practically everything about Mars that you can think of, has worked on multiple engineering projects. And so we wanted to bring on Max Fagin to talk about the engineering difficulties in landing a rover, landing anything and bringing anything to Mars. So let me bring Max in right now so he can kind of generally speak to the engineering difficulties. Hang on one second. There you are. Oh my gosh. Look at that background. Oh, you give me a lot to aspire to, Max. I'm not gonna lie. I am very jealous of that background.
Well, can you hear me?
Yeah,
I can hear you perfectly.
Excellent. Excellent.
How you doing, Max?
I'm doing really well. Great day.
It's a good day. There's a lot of energy happening today. There's a lot of emotions, a lot of excitement. And
everything's gonna go great. So yeah, we don't worry at all. We don't worry one bit.
No, that's why
we're in a position where if anything goes wrong, it'll be beyond the control of any of us. We've done everything we possibly can to make things go right.
Yeah, exactly.
Yeah, literally at this point, there is nothing else that can be done. Everything is on course, and it's crazy now because they took a lot from what they learned from the Curiosity landing, and they actually adapted it to this one. So even though the entry, landing and descent, entry, descent, and landing is practically the same, there are small changes that they were actually able to make. Such as when they deploy the giant parachute, that would actually make it easier to pinpoint exactly where they're going. So that's besides the point. Max, from an engineering standpoint, if you could please tell us, how difficult is it to land something on Mars?
I would say landing something on Mars is the hardest challenge in uncrewed spaceflight that humans have ever attempted. There are harder challenges when you bring people into the picture, but from a robotic planetary exploration perspective, landing spacecraft on Mars is the hardest challenge we have ever encountered. It combines the worst constraints of heating, of guidance, of software into a really terrible package that it is just remarkable that we have been able to have such a remarkable track record with.
Yeah, I was listening to a lot of the NASA live feed earlier today, and one of the things that they were talking about is, this is a mission with 2 million lines of code, miles upon miles of copper wiring and transistors. I think it was like 70 pyrotechnics that need to go off during the descent and the landing. Yeah, you're really just talking about a multitude of different factors that all have to come together and work out perfectly to bring something that's traveling thousands of miles per hour to gently touch down at a meager, like, I think it's like 3 miles per hour.
About 1 to 2 miles per hour vertical rate. Yeah.
So it's incredible. As an engineer, then, what do you think is going on in the minds of everyone in the control room right now? We already said that there's nothing else they can do. I mean, I can't even begin to imagine how they're feeling. I'm nervous, and I don't even have a stake in this. I can't even imagine this is something that has been years and years of work for some.
Yeah, they can be.
Well, that's
completely. Yeah. So it's.
Well, that's what's excellent about the way responsibilities are broken down on landing day. Everyone has their responsibilities pared down to something that they can think about. In a way, we have it a little bit worse because we removed outside the program. We see the entirety of the mission and we stress about the entirety of the mission. But on landing day, when you're in mission control, you have a fixed set of narrow responsibilities, and it is just your job to make sure that those things go right. So in a sense, it's a little bit liberating.
Right.
Unless you're the program manager or the mission director, you don't have to worry about everything that could possibly go wrong. It's only your responsibility to get these 50 tasks right, and if you do your job, your teammates will do their job, and the spacecraft will get down safely.
Yeah, you're talking about years and years of work that some of these people dedicate into these experiments, into the software, into the hardware that goes on to here, and it all comes down to this one moment right now where it's going to make it or break it. It's huge. I mean, there's a lot going on right now. Oh God, yeah, I can't even begin to imagine what they did.
Yeah,
we are even approaching the landing point. So yeah, the excitement is growing everywhere, I guess.
Yep, the official end of the cruise phase coming up in just a couple of seconds. The spacecraft is going to separate from the cruise stage has just separated. So the spacecraft is now going to start detumbling, so the spacecraft is no longer in its spin stabilized attitude, and will adopt a new attitude that will allow it to stabilize against the aerodynamic loads that are pushing on the vehicle. The spacecraft is actually trimmed with a slight lift over drag, so there is, instead of coming in straight like this ballistically, it'll actually be coming in at a slight angle of attack, gives it a little bit of lift. And that's one of the ways that it's going to be able to achieve this really high landing accuracy, because the spacecraft is able to, by rolling with that lift, get a little bit of cross-range control and steer itself to the landing site. The earlier spacecraft would actually trim to a fixed angle and then have a very limited degree of control by actually spinning. And by if you stop the spin in one direction, then you trim in, then you swerve off in a different direction. But this entry is much more stable. It'll be holding lift vector up for most of the way, with just a little bit of side to side trim by spinning.
And I know, as I mentioned before, they're not even deploying the parachute at this point in this mission.
Oh no. No.
They actually, they're actually waiting on it a little bit. I know Curiosity, the factor that went into deploying the parachute was based off of the velocity at which it was entering the atmosphere. This one is different. They actually decided that it's going to be a much more accurate way of landing in their targeted area if they take a composition of the atmosphere, kind of like that drag that's being pushed up against that, and use that data to then deploy this massive parachute that's literally the size of like a Little League baseball field.
Mm-hmm. There's lots of different ways you can trigger your parachute logic, but part of the problem is there is no way to determine precisely where the vehicle is in its entry corridor. There's no GPS on Mars. And until the terrain relative navigation can get a sight of the ground below it, the vehicle has no precise idea where it is.
Yeah.
We can come up with a pretty good estimate by using onboard accelerometers like the kind that are in your phone, and by integrating out what the accelerometers are saying. That process can get a little error prone if you don't apply a correction, but this time by integrating out the accelerometers and looking at the dynamic pressure of the air on the vehicle, the parachute is actually going to be triggered by range, by when the vehicle thinks it is over its intended landing site, rather than by altitude pressure.
Yeah, that was so you mentioned the terrain relative navigation. Is that right?
That's right. Yeah, terrain. So there's multiple ways that the spacecraft at this stage can keep track of where it is relative to the ground. But the most precise way is to have cameras that look down at the surface and match what it's seeing to a map, to a pre-uploaded map of the surface. That's the most reliable way to get a location fix if you don't have GPS. It requires very accurate maps. It requires precise understanding of the lighting conditions on the day of landing. But this will be the first time that this system will be employed in a Mars lander. It's good enough to actually exclude areas inside the landing ellipse to keep the vehicle clear of hazards.
Yeah, it's a lot of it's insane to me that a robot, there's a lot of communication happening within the robotics. So the terrain relative navigation is communicating with the Mars Reconnaissance Orbiter's imagery to match that imagery up that it's taken from orbit to what it's currently seeing on the ground. And then it's going to take that data that it sees and that's matching and do its best to navigate around in that area.
That's right.
Yeah.
Yeah, we have a question from Dan on the chat. He says he would love to know, when do the 7 minutes of terror actually occur? At what point?
As far as the rover is concerned, it's starting right about now.
I was just about to say
the rover is currently in the middle of its descent. In fact, let's see, 11 minutes plus 14.
Actually,
it should just be passing through peak heating now, if I understand correctly. But because the signal from Mars is delayed by 11 minutes,
right.
We won't know for sure until 11 minutes later.
Yeah, it's right, exactly. So we know that there's that 7 minutes of terror when it's first entering the atmosphere, going from there to landing, and that happens. I think that's 3:55. Is that correct? Let me take
3:55 is entry interface, I believe. Yes.
Yes. And so really, by the time that we even get the 7 minutes of terror notification here, because of that light delay, the rover will already have been on the surface for about 4 to 5 minutes.
That's correct. I'm just saying, I'm glad this entry capsule is also a stress ball.
I saw you squeeze it, and I was like, oh my god, that was really strong. But yeah, okay, it's just a stress ball. That was,
actually, I thought he was just mimicking something that's going to happen to the capsule. But
God no. Wave off. Yeah. So actually, the aeroshell, the back shell, is going to separate from the vehicle shortly during the entry process, and it will be crashing onto the surface, but not so hard because it'll still be under parachute. It will be coming down softly enough that there will probably be debris to find. It won't leave a crater. Mars, I think, Curiosity was able to actually find its back shell on the surface after roving around for a little while. I don't know if that's planned for this rover, but it's certainly a possibility. The back shell is not destroyed after entry.
Now, one of the questions that I had seen on social media was regarding the sky crane. So I know with both Curiosity and Perseverance, the sky crane is going to lift, or is going to gently descend the rover onto the surface, and then essentially it's just like, peace, like I'm booking it out of here, and it just jettisons off as far as it can go based on how much fuel it has.
Mm-hmm.
One of the questions though was, how salvageable is that thing going to be? Can a future colonist or Mars explorer recover that piece of sky crane and do anything with it, or is this thing just like on a one-way course to obliteration?
It's going. There would probably be souvenirs that you could salvage, but not useful equipment.
Yeah.
I mean, the vehicle is not designed to survive anything like a hard landing on Mars. Everything that is going to Mars with Perseverance has been weight optimized just for the loads it needs to see. And in this case, that's the loads of reentry. It's not designed to survive a crash landing. So there won't be much left, but there will probably be some souvenirs, and I hope some future Martian tourist is able to pick those up.
I can only, when you're on the surface of Mars in the future, as an Earthling, I would just imagine anything you touch is just going to be a souvenir. But to a Martian, yeah, it's probably going to be a lot of that debris that they share as well. An image of that. Okay. Max, that's great. Obviously, I think we have about a minute left until everything enters into the atmosphere. We can let you go so that way you can kind of de-stress as well. But if you want to come join us back on here after the landing and laugh or cheers,
celebrate the successful landing,
hopefully not cry, then you're more than welcome to join back on.
Copy that. I will see you when we're on the surface.
Awesome. Sounds good, Max. Thanks again. Really appreciate you taking the time. Max, the amazing engineer, on with us.
Take care, everyone.
Take care, Max.
Bye.
All right, so I've got the live feed up now. I think you can actually see it. Yeah, perfect.
Yeah.
All right. Oh man, I am
So
stressed.
I wanted to make a point, and I wanted to make that point for some time now. I've been Perseverance is going to land in the Jezero crater, right? Not the Jezero crater, as they call it. Jezero is actually means lake in Croatian, Serbian, Bosnian, and some other Slavic languages. And it actually got a name from a town in Bosnia and Herzegovina, which is called Jezero. And I see Chris McKay actually.
Yes.
here.
Sorry, I didn't mean to cut you off there, but
No, that's okay. I can continue my Jezero story later, but I think we have now Dr. McKay, who is.
Yes. Sorry. Thank you.
Me, so yeah.
I just I have some of the live stream going too. Okay. Dr. McKay, I believe you're on here too. Thank you so much for joining us. You're a planetary scientist with NASA, well-renowned in your field. I know we only have a few minutes now until we kind of touch down on Mars, but we wanted to get your input as to the search for life on Mars. What are you kind of hoping to see? Well, first of all, thank you so much again for joining us. Really appreciate it. But what are your hopes and dreams kind of for this mission? What's the best case scenario that you're thinking here?
Well, the reason this site is interesting is because there's evidence that it had water billions of years ago. So water is the key requirement for life. So if our hopes are correct that we might land here and find evidence that there was life at this site billions of years ago, and it might have left a record in the chemicals in the sediments. And this rover is going to look for those chemicals, look for that evidence using various tools, spectroscopic tools on the rover, and it's going to try to bring a sample back eventually. So it's going to collect samples to bring it back. So this is very interesting. It's been a busy day. I meant to get on earlier. Sorry, I'm a little bit late, but it's very exciting and very busy day.
It's just been a highly emotional day for a lot of people here. I think that's something that there's a lot going on with Perseverance, and I really think the biggest thing that's going on with Perseverance is the fact that it is searching for life. I mentioned it earlier, but the Curiosity rover, when we sent it there, a lot of people thought this is going to be searching for life. We're really excited. And then people found out, oh, actually, it's just searching for past habitability. Now, habitability and life are two different horses at that point. You've got habitability, which can life be supported in these conditions? And now
Right.
exactly what Perseverance is looking for is, okay, now that we know Mars at one point was habitable based on Curiosity's findings, can we find any life? And that is huge.
Yeah, well, you're right. Curiosity officially was focusing on habitability, but it did some very interesting experiments and measurements, particularly the first real detection of organics was by Curiosity. And the investigation of habitability, as you said, habitability is a necessary, although not sufficient, requirement for life. So you've got to have habitability. Curiosity really showed that Mars really was habitable, in particular, these spots where there was water billions of years ago, habitable in the past, habitable billions of years ago. So we're always in these kind of sites, Gale Crater, the current Curiosity
Right.
site, and also the Perseverance site are looking at locations where habitability billions of years ago could have supported life.
Now, what, without, I guess, I know it's going to be a difficult one to say without going into any details, just because I know time is a little bit short here, but, what are some of those markers that Perseverance will be looking for? Like what are we?
Right. Well, the most interesting markers of biological activity are amino acids and lipids. Amino acids are the building blocks of proteins. So proteins in your body are made up of amino acids. Now, they also occur naturally in meteorites and in Miller-Urey type synthetic experiments, but the biology uses a particular set of amino acids in a particular pattern. So that's a signature of life. The other is the fatty acids, the lipids that are used in membranes are distinctive. And so those are the best biomarkers to look for.
Perfect. Dr. McKay, Igor, I didn't know if you had any questions for Dr. McKay.
What was, sorry?
Did you have any questions? I didn't know if any of our users.
I got a question also on social media, which was something about how long would it take to study a sample from Mars? So how does it go? How you take a sample and then what exactly do you do with it?
Okay, on Curiosity, we do take samples. We put them in little ovens, for example, and heat them up. Sometimes we add chemicals to it first and then heat it up. And then the fumes from that heating process move through an instrument that separates the molecules and analyzes them. So that's done inside the rover. And there's a scoop to pick up the sample and put it inside. Perseverance doesn't do that. Perseverance doesn't take samples for analysis in the rover. All of the analyses, the scientific analyses on Perseverance are done remotely using lasers. So you shine a laser on the soil, on the sample, and then you look at the glow, either using Raman spectroscopy or ultraviolet fluorescence or some method which allows you to identify the molecules by the way it reacts to the laser. So there's no requirement to pick up a sample, and there's no instrument in Perseverance that will receive a sample to do analysis. It's all done remotely. So the good thing is that you can do analysis much faster. You don't have to pick up a sample. You don't have to move the rover right next to it. You can just shoot and look at the signal. It's a step toward the tricorder.
That's incredible. No, that's amazing. Dr. McKay, it pains me to have you on for just such a short time. I'd love to invite you back again for more Mars talk. I think you'd just be a wealth of information, and we'd love to be able to do some videos with you. I'm seeing that on the live feed right now from NASA. Right now, what we're seeing is I believe the rover, if everything has gone according to plan, the rover just landed.
Yeah, just landed, yeah.
Yes, on the surface.
Okay, but we don't see the signal back here for some time later.
I think it's going to take a few more minutes. So
okay, okay. So I think we have confirmation because everybody at NASA just went wild.
Well, they went wild. I think they're excited because right now it would have landed. So we have about 11 more minutes to confirm that it actually did land.
I got excited too.
I know. I'm just as excited. Okay, well, that's very exciting. All right, well, yeah, Dr. McKay, thank you so much for taking the
You bet.
time.
Yep.
Um,
Let's
yeah,
talk.
like I said, please, don't be a stranger. But again, thank you so much for sharing some of those insights.
You bet.
And we'll be in touch with you soon.
Okay.
Thank you very
All
much.
right,
Bye.
take care.
Bye.
Good talking to you. Bye.
Good talk. Oh my gosh. I saw the live feed going and I was like, oh my God.
Yeah, I think I got too excited too fast. Yeah. So
I thought we were all gonna jump up and go, yay!
yeah.
I was sweating. I'm like, I'm like sitting in my chair.
We're all gonna take part in the JPL. Done. Sorry, I'll go now.
No.
Oh
No.
my
You
God.
don't really have to go. You can join us. It's okay.
That was pretty cool to be able to have Dr. McKay here and talk about it. And while it's landing, I don't think I've ever, in all the almost 20 years of being with the Mars Society, I've never done that. Done some pretty amazing things with Dr. McKay, including looking at 3.5 billion year old stromatolites, ancient cyanobacteria, life forms on Earth that helped. That actually, we wonder if Perseverance might see some of that. Some sort of fossilized early microbes that helped, that didn't get to go as far as we have on Earth, but
Yeah.
for obvious reasons.
That's one of the cool things that Percy is going to be doing is she's going to be looking from the ground for those types of rock formations that are going to be indicative of perhaps maybe like signs that it was in the presence of water, or water affected it somehow, or maybe even something that's similar to some of those signs of life that we have here on Earth, that are much more primitive.
Well, that's one of the things that the UAE is going to be looking at, the atmosphere, and why is Mars's atmosphere so thin?
Right.
How much of it has been lost in space? What's the rate of loss in space? Which is so exciting that we've got 3 different missions going on Mars this time around. We could have had a 4th with ESA's Rosalind Franklin rover, but they're holding off until next year, 2022, with the landing in 2023. And we won't get those cache samples back until 2026. So we've got, we always get some great data back from these rovers, though. Lots of great imagery, and of course, data loggers that are telling us all about what's happening on the surface of Mars. So, and I just wanted to know, did it get confirmed? Some people are saying on YouTube that maybe we've celebrated too quickly, but I see everybody clapping.
Oh, you know what? Then maybe
Is that a picture? First picture.
The first picture. Oh wow!
Yeah,
Oh, yeah.
I would have celebrated so much more.
That was right.
I was at the landing party in 2004 for Opportunity, and I just remember the pictures were right away. So I was
Okay. So, yeah, I have to correct my comment on YouTube because I said I got ahead of myself.
well, congratulations, NASA, JPL, for their landing.
Congratulations!
Again.
That's incredible.
Landing on Mars. Pretty amazing.
Oh my gosh! All right, wow. Well, that's huge. Yeah, congratulations. We did it. I mean, it's there. We've got some serious science ahead of us now at this point. We also need to see which of us, Igor, wins the pot.
Oh yeah, definitely. Joe and I had kind of a contest to see who is going to guess the exact area of the landing in the Yezero crater.
Yeah.
So my part, I'm really anxious to see. I mean, I think I won, but hey,
Have they said where?
Do
they know yet?
we
Where?
didn't get anything. We should have.
No, I haven't seen any images yet. I haven't seen.
It's too early, I think.
We see a picture, but I'd love to know if they're on the delta, or how far away they are from the delta.
Yeah. So.
You know, something really exciting too is I know a lot of. Oh, look at that picture.
Oh.
Something that I, whenever I talk to people about these types of missions or Mars, is they were like, oh, will we be able to see the landing? Like, will we be able to see like a live image of it landing on Mars?
Yeah, but we'll be able to get the replay probably of what the cameras, because this rover is like completely pimped out compared to Curiosity.
The resolution on the way down is going to be, because I remember the Curiosity did something very similar to that as well.
Well, this one has
really
like
cool.
23 cameras, way more cameras, higher resolution cameras. It can look farther, which hopefully means that the rover will be able to travel a little bit faster than Curiosity. But I was saying it's the same chassis, same size as Curiosity, but Perseverance is really kitted out. And of course, like you mentioned, it's also got a helicopter on board.
Right. Can't beat a helicopter.
Yeah, and the helicopter can cover way more area, like Dr. Zubrin said also.
So it's mostly there for testing if we can fly in the atmosphere of Mars, because it's so thin. Will we achieve flight? And if anything, most of the time it's it's going to be sitting there kind of recharging its batteries and seeing how the flight, it's almost like a hopper really. So the idea, a helicopter that'll be flying around, and it's mostly just for experimentation, but all good stuff, all good research and data.
That's incredible.
It's very nice to see happy faces there, NASA.
Yeah, I was wondering if the watch party on Facebook was still on, and if Dr. Zubrin could come back, I could give him a.
Sure. Hey Joe, by the way, this landing is also great for us, because it would really be bad if we had an accident or something on our first live ever.
Oh my gosh!
Kind of
Can you imagine?
Yeah.
I've been really bad.
I'd be depressed, probably.
I'm gonna try and get some of the sound through from the live feed,
Sure.
just so we can kind of hear what they're talking about. I'm gonna mute my.
I'm gonna mute myself too, so you do your magic.
Experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions, and then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars, and then for human exploration. We have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade, and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2. And that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech.
All right. I wanted to also bring Dr. Zubrin back on. I know they were kind of going through some of that, but welcome back, Dr. Zubrin. Congratulations. Cheers. Very exciting time for us. How are you feeling right now?
I'm feeling great. They're making it look easy, but it's not easy. And it's another remarkable success. And this is now NASA's 5th in a row successful Mars landing. Spirit, Opportunity, Phoenix, Curiosity, and now this. So failed in 1999, but since then they have succeeded every time.
Yes. Yeah. I mean, it's, it is incredible. We had Max Fagin on to talk about some of the difficulties and the sheer amount of things that can go wrong with these types of missions. Like I mentioned, 2 million lines of code, miles and miles of copper wiring and transistors. You've got the pyrotechnics. You've got the sky crane that needs to land the rover safely on the ground, and they do it. I think a lot of what they're able to do, fortunately, is build upon the previous missions that they've had. There were some things that, even though it looked very similar with the entry, descent, and landing from Curiosity, they took some of what they learned from Curiosity and they put that into the Perseverance rover. That's why they were able to actually make that landing area so much smaller and pinpoint it so much more exactly. I just personally can't wait to land a person on Mars, Dr. Zubrin. I know it's difficult putting a rover on Mars, but I can't even imagine how difficult it is putting a person on Mars.
Well, certainly there's a lot more risk when you send a person, but it's actually easier to do successful space flights with people on board because they can correct the problem. The moon landing would have failed if Neil Armstrong hadn't been there on the stick. The Soviets failed in every single Mars mission, but almost every one of their manned missions have succeeded. Because with people, you have that resiliency. People say the human being is going to be the weakest link in the chain of the Mars mission. Actually, it's going to be the strongest link in the chain.
Right. Yeah, I'm wondering then, because they're able to learn so much from each of these missions and build upon that. Do you think there's a lot that we can learn about landing humans on Mars, even just from these rover descents? Is there something that we can take away from these to make it safer for people to land on Mars?
Well, sure. Look, every time we do one of these landings, we're learning about what the winds are like in that last kilometer down from the high altitude right down to the deck, and what we might expect, and things of this. And of course, look, we're not going to use a sky crane in landing human spaceships on Mars. Certainly not. Starship won't. But we'll learn about the dust that you kick up and whether you dig a crater with your rocket thrusters and exactly to what degree that is a problem. But beyond that, we're just learning about Mars, and we're going to learn where we should go on Mars. And I heard a talk by some NASA scientists last year in which they said we're sending robots so we can find a place where there's no life on Mars, so we can send people there. Exactly the opposite. If we find a place with life on Mars, that's where we want to send people, because that's where the greatest science is to be done, the science that merits taking the costs and risks of sending humans to Mars, to find out the truth about the prevalence and, more importantly, the potential diversity of life in the universe.
Yeah, you've definitely, they've picked the right place with Jezero Crater. It's, you look at some of the images of what it potentially used to be, and even now it's so clear to see from some of the satellite imagery that there was liquid water just pushing everything into this lake right here, into that delta.
Yeah, but there's a lot of interesting places on Mars. We got to send a lot more probes to a lot more places. If someone landed a lander in your neighborhood, how likely would they be to find a dinosaur fossil? We didn't find them until we had explored Earth quite a bit, and there's always amazing new things we find whenever we go to a new kind of place on Earth, like the sub-ocean vents, high temperature vents. There's all sorts of things, and we need to go to a lot of places.
I'm hoping with
Sorry,
with the prevalence of, with the prevalence of missions that happen this month, and we touched about this earlier when you were on the call, just all these countries that are just like racing towards Mars in a positive way. We're not competing with one another. We just all want to understand Mars. I hope that we do see something moving forward where, every 2 years, you get Australia going to Mars. You've got South Africa, you've got Egypt, like just all of these programs that just kind of pop up because, with the technology that we have nowadays, it doesn't take a lot. It doesn't take a superpower to send these missions over to Mars.
Correct. So
That's what-
yeah, I would like every 2 years, the United States sending a powerful rover or maybe a helicopter as well as an orbiter to Mars. And I'd like to see 3 or 4 other countries every other year send something to Mars. In other words, we should have half a dozen things going to Mars every opportunity from a diverse collection of countries.
And China is next, actually, landing in May.
Yeah, I know all this excitement now, but we have a couple more months now, I think, until they land their rover and their lander.
Right.
They're also landing in a different place, so one more place to be explored, I guess.
That's true.
Yeah, that's exactly what you're saying. You know, the more presence we have on Mars, the better it is. The better chances there are that we are going to find either life or the best place to land or the best place to land humans. So, but we have to be present. We have to be there, and we have to be there in numbers. You know.
Right. So if we land a Starship on Mars, maybe we could land, say, 30 or 40 rovers and, 10 or 20 helicopters with it, and deploy them out and really explore in all directions. And not only that, with rovers and helicopters, film the whole region of the landing site, transmit the data back to Earth, and create a virtual reality simulacrum of that area so that people on Earth can start walking around that area and investigating it. And if they find things that are interesting, point them out, and they can send a rover over there and hit the rock with a hammer and see if it's really a fossil or a mineral.
Well, I'll do you one. I'll do you one better, Dr. Zubrin, too. What I would like to see is a whole fleet of helicopters, bigger ones, because this is just like we said, the Sojourner of powered flight on Mars. I'd like to see some Curiosity helicopters with a whole bunch of Sojourner type of rovers on there. Deploy the rovers on your location and move on to the next one.
I agree. That's exactly what we should have. I don't think necessarily the next step is Curiosity-sized helicopters, but Spirit and Opportunity-sized helicopters could carry around little rovers and go to all sorts of places.
One can dream. One can dream. There you are, Max.
Well, from imagination to reality.
Yes. It's one of those things too, where you kind of, you got to build off of kind of what you're doing at this point. And so baby steps, but maybe one day in the future, we'll get something cool like that, I think. I think they just ended this live stream. Max, I see you're back on. How you feeling?
I'm feeling awesome.
We all celebrated like 5 minutes after the fact. And so, yeah, nice.
I celebrated first, just for the record.
Yeah, red lemonade for a red landing.
Celebrating because they said, no, it didn't land yet. It didn't land yet. So I was right, just for the record, since it's recording. Yeah.
Hey, do I get to join the party too?
Please,
Absolutely.
come on in. We all need to. Lucinda, you were there with us when we thought they landed, and then we didn't think they landed, and then they did land, and then we celebrated like 5 minutes later. We were on Martian time, actually. We were just waiting for the signal to get back to Mars from Earth. That's all that happened.
I was. And what's so great about some of this NASA live feed is all the children that they're involving and the pictures that they're drawing about a future on Mars. I think that's exactly what all of this work does, is inspire the future. What is that line that you wanted me to say, Igor? It's the risks that we take that inspire the young. And I think that's what, humans landing on the moon did for that generation. And it's really time to inspire the young generations that are going to kind of carry the torch from this forward. But how soon does Elon want to get humans on Mars? Is it still 2026?
Now, Elon wants to get humans on Mars by 2020, but no, Elon is, saying 2026 or so. But look, there's two things about Elon. One is he is generally rather optimistic in his schedule projections, but the second is he eventually does get it done. And so, in other words, Starship was supposed to have reached orbit already, and that's still a ways off. My guess is it will reach orbit next year. Could happen this year, but my bet would be on 2022. But okay, Starship reaches orbit in 2022. Fine. and then has regular service to orbit by 2024. At that point, probably we're looking at possibly a robotic landing on Mars of a Starship in 2026, or certainly by 2028. And we do that, we could let loose dozens of robots. And by that time, not only wheeled robots and helicopters, but I would think by that time we've got humanoid-ish robots. I don't mean intelligent, robots, androids and things, but I mean telerobots, but nevertheless have mechanical systems that allow them to walk around with people with arms, and thus you can actually build a base. You can deploy networks of solar panels. You can set up an ISRU plant. They can do a whole bunch of things, basically set up the base, create propellant production facilities. You could use a landed Starship as a propellant depot itself. It has big tanks. And then maybe send the humans out in 2030. But here's the thing. SpaceX is able to develop Starship on its own money because Starship has direct commercial applications. They will use it to launch constellations of satellites and orbital research labs and what have you. There's a whole bunch of systems necessary for a human Mars mission that do not have direct commercial applications. And some of them, so therefore, are difficult for a company to justify from a business point of view. But beyond that, some of them even are difficult for a private company to do at all, such as to create a space nuclear reactor, which involves a highly enriched uranium-235, which is a controlled material. And therefore, the way I view this thing, the way this is going to unwind is Starship will be flying regularly to orbit, say, by 2024. Well, then, okay, we're going to have an election in 2024. Somebody's going to be elected president. And if Starship is flying regular to orbit, Saturn V class payloads, 1% the cost, though, that person can, or at least should, turn to his or her advisors and say, look at this. This guy wants to send humans to Mars. He's got this ship. If we got together with him, could we do it? And the answer is yes. It's a whole bunch of other stuff he's going to need, but we could develop that within NASA's existing budget. And we get together with him and we go together to Mars. This becomes a public-private partnership. And by making it feasible, by developing the single most important and most expensive and most challenging part of the Mars mission, which is the transportation system, is going to make the mission sellable. And I think that will change the agenda at NASA and ESA from the kinds of things they're thinking about now, because this will be in sight. And so I think, yeah, humans on Mars by 2030 is a definite possibility. And certainly the information we get from a robust robotic exploration program, including, I'm hoping this helicopter will pan out and we'll have vehicles that can travel hundreds of kilometers a day instead of hundreds of meters in a day. And it can do extraordinary reconnaissance, both in advance and in coordination with human explorers on the surface. That'll be tremendous.
Yep. And the timeline for that actually works out very well. Sending a robotic Starship, an uncrewed Starship, to Mars in 2022. 2022 is one of the fastest arrivals, hardest transfers. So it would be an excellent time to get an enveloping case of how Starship performs, because after that it starts to get considerably easier, which would be a perfect time to send humans in the late 2020s or in 2030, because you get the maximum safety, most amount of payload for crew operations. But 2022 would be a great time to send an uncrewed Starship to Mars to verify the system.
Yeah, once you do that, then really, Dr. Zubrin, I see once you make it easy to bring these missions over there, that is when you're going to get almost every country with some type of, foot in the game kind of thing to get out there and put their payloads on Mars. That's when you get 20 different countries loading up their missions onto a Starship, shooting it out there, and then everyone's got to.
Well, sure. At that point, all you have to do is build your own kind of Mars rover.
Right.
So, for instance, Poland is great at building rovers. They win our Mars rover contest practically every year, well, they'll want to send a few rovers to Mars, and the cost won't be that great. It'll be easily within their means. So all kinds of people with surface science to do. Well, of course, Starship could stop off in Mars orbit and dispatch a whole load of orbiters as well. Right now, of course, with Falcons, they're launching 60 satellites into Earth orbit at a time. Okay, why not launch 60 orbiters into Mars orbit at a time? That'd be something.
I have a question from somebody on social media, and this is one thing I've heard a lot of times when we talk about colonization of Mars or sending humans to Mars, is that it's dangerous. So it's, in my opinion, of course it's dangerous, but that doesn't mean that we shouldn't do it anyway. Because if we always stay in one place, we would never advance. So what would you say to a comment on that?
Well, look, no one's being drafted to go to Mars. This is a risk that people are going to take voluntarily. And, people take risks to climb Mount Everest for no other purpose than to prove that they're up to a challenge. Here we're talking about people taking risks to potentially do great discoveries to accomplish great things for humankind. Look, it all depends upon what your definition of the good life is. If your definition of the good life is living in safety and comfort, then don't go to Mars. But if your definition of the good life is having a chance to do great deeds, then you might want to consider going to Mars.
There's one also question that is, I think, very good. So do we think that a comprehensive Mars satellite network is essential for humans on Mars? So do we have to have something like that to be,
is it essential? No. Would it be useful? Certainly. No, but the idea that you have to have, look, people lived on Earth for a long time before we had comprehensive satellite networks here. And frankly, long, even air travel was done without GPSs. They simply put beacons down in different cities, and airplane could find its location by triangulation. Couldn't get it to the meter accuracy that you can with GPS, but to imagine that you can't navigate without a GPS is just nonsense. And in fact, people navigated on Earth and quite accurately before there were even Loran radio beacons. They used celestial navigation. So that's possible too. But I think eventually there will certainly be navigation satellites on Mars. One of the simplest satellite navigation systems that ever was called the Argos system, which only required, it only really requires one satellite, although I think they had two, where you put the satellite in a polar orbit and you know where it is. Okay, that is, the satellite's orbit, and you got a clock, so you know where it is. Well, when it comes close to you, that tells you your latitude. Okay, and furthermore, since you know its longitude in general, the Doppler shift of the radio signal from it to you or you to it tells you how far to the side of its ground track you are. And they use these things to track like dolphins and falcons and so forth, just putting little radio beacons on the bird's leg, and they could track it all over the world with accuracies of a kilometer or so, which is good enough if you want to, for instance, find your way back to the base from being out in the middle of the desert, and this sort of thing. So putting simply two satellites in Mars polar orbit would give you an Argos type system right there.
Thank you.
That's perfect. Yeah, I'm trying to think of the next steps now for Perseverance. I think at this point it takes some
it's
time.
going to go to sleep.
Yeah, it's yeah, exactly.
It's almost sunset at the landing site. The sun will be going down in a couple of hours, and the batteries are need to be charged up overnight.
Max, do you know when when Ingenuity might be deployed?
I think it's July 30th. I think was the date I saw.
Okay.
Yeah, I don't.
Well,
I
they
don't
should
know
do
for
it
sure,
on
but that
July
sounds right.
4th.
I agree. I think that would be incredible. Have like a little firework kind of shoot off from it, and yeah, July. And then I don't believe the first rock sample is even going to be taken until spring. I think they have a few months of kind of assessing the area in which they landed, picking their first targets and the path forward, and then they'll start drilling for some of the rock samples. So,
Well, they'll have to find an area where rock collecting is permitted.
They land and there's just a whole bunch of signs all around them saying no trespassing.
Yeah.
I don't think the Martians would be too happy about that. Yeah, really kind of the next big thing now at this point to look forward to is Tianwen. I think Tianwen landing sometime in April.
July.
Is it July? Oh,
Yep,
for
July.
the Ingenuity. Yeah.
July 23rd, I
the
think.
Chinese lander, I believe, was May.
May.
Yeah, I think it's May. I think Max was saying for the Ingenuity.
That was May 8th, no?
Let me check.
I'm pretty sure it was either April or May. I want to say.
I remember May, but yeah, let's not.
And I think actually the
on
Chinese
the
have a
lander.
very important holiday in May of national political significance.
Okay.
Somebody could Google it. I think where China first became a republic, overthrowing the emperor, if I'm not mistaken, and I wouldn't be surprised if they land on that day.
You're right. Yeah, May 2021.
They timed the arrival to Mars really well with the Chinese New Year, so that would be fantastic if they could time the landing.
Yeah, they timed it really well with the Martian New Year as well.
Yeah, we have an interesting question here on YouTube, and the question is by Cobra D. So I guess that's a Nick. So how would finding evidence of life on Mars affect future Starship, for instance, landings? Would it be moved?
Well, no, it certainly won't be moot, but there's actually two answers to that. The answer I favor, and which I think is the rational answer, is that it should say this is a very important reason why you should send people to Mars. There's great discoveries there to be made, and to follow this data up, you need to send the best possible explorers you got, which are people. Okay, and certainly, when you find something on Earth that begs further investigation, you send scientists there. You don't say no one can approach this. Then there's other people who are going to say no. We have found evidence of life on Mars. People must stay away because it will contaminate the data or something. And this, to me, is an entirely false position. This idea that you wouldn't be able to discriminate between life you found on Mars that you brought between and that what was there before you. I mean, how do we know there was life on Earth before us? Because life that existed on Earth before people left fossils and other biomarkers. That's how we know that life existed in the prehistoric past. Well, similarly, if there was life on Mars before we got there, it will have left fossils or other biomarkers. Life leaves wastes around, okay? And there's no two ways about it. And to believe that we wouldn't be able to know that life was there before us, it's like the creationists who say that we don't know that there was life on Earth before us because God could have created the Earth with fossils in it. Okay, so this is nonsense. Okay, now if you go to Mars and you find life, okay, first of all, obviously, if you find life that is different from Earth life, you also know you didn't bring it. But if you find life that is identical to Earth life, but you find biomarkers, then you know it was there before you. If you find life that is identical to Earth life, but you do not find any biomarkers, it means you brought it. That's all there is to it. But, the thing about life on Mars, it's not just a question of whether there was life on Mars. It's a question of what is the nature of life on Mars. That is, does it use, for example, the same information system as Earth life does? All Earth life uses exactly the same information system, DNA and RNA. It's like, English uses the Latin alphabet, so do the French, Spanish, the Germans, even the Poles, okay? And that's because of the spread of the Roman Empire or the Roman Catholic Church. But there are other alphabets. Okay, the Russians use the Cyrillic alphabet, which is derived from the Greek alphabet, that uses some different letters, but it works on the same principles as our alphabet. The Israelis and the Arabs use a still more different alphabets, but ultimately they work on the same principles because we all have a common origin in the Phoenician alphabet. But the Chinese use a completely different alphabet. It works on a totally different set of principles. It's not based on sounding out words through sounds. It's based on pictures that are combined in various ways. So it's a totally different principle of conveying information. Well, but you can still write books in it, just like you can in the Latin alphabet or the Cyrillic alphabet. And so the question is, if life on Mars, is it the same as Earth life? Do they use the Latin alphabet or do they use the Chinese alphabet? There's what is the possibilities for life and what life could be and what possible information systems and other systems, metabolic systems and so forth could it use? This is going to take human explorers, okay? You're going to have to send people to drill, reach the groundwater, bring up samples, subject it to biochemical analysis, try to culture it, see what's there. That's what you're going to have to do to find out the truth about life on Mars. Because, if Perseverance finds fossils, stromatolites on the surface of Mars, that'll certainly be very interesting, but that will not prove whether it evolved there locally or whether it was spread there from meteors from Earth, or both Earth and Mars were seeded from spores from interstellar space. Won't tell you anything about the nature of life. If you find life on Mars with a different information system, that means they both evolved locally. They were not seeded from the interstellar source. But I mean, if you really want to do exploration, you got to send people. I mean, look, the reason why, what planet do we know the most about? Earth. Why? Because we are here. If you want to know about Mars, go there.
Yeah.
Max, I know you've got to take off, right?
Yes, I do. But thank you so much for having me on. This was wonderful to watch. I'm so proud this went.
Thank you. We really appreciate all your expertise and you making the time today. Please don't be a stranger. We love having people like you on who actually know what they're talking about. Igor and I don't know what we're talking about half the time. So it's people like you who give us some credibility. So thank you.
Copy that. Have a great rest of your day and on to Mars.
Yeah.
On to Mars.
On to Mars. Sorry. The future first Martian actually just needed to pop here a little bit. So.
What's her name?
That was Amelia.
Amelia, first person on Mars.
So she'll be the first person on Mars for sure. I think, probably about like 18 years or so. Maybe she'll just be the youngest person on Mars then. I'll be happy with that. So.
Yeah. Look, I'm going to have to go now too, but this has been a great day, and thanks for inviting me and
Dr. Zubrin,
giving a chance to share with everyone.
Pleasure having you too, Dr. Zubrin. Thank you so much for taking the time, and thank you so much for talking to us and to the audience.
Okay, as they say in Russia, poехали.
Or in Croatian, do viđenja, vidimo se.
Hey, you guys, I'm going to let you guys close out. I just want to say thank you so much. Well done. Good job. And I hope to see more of this for Mars Society Education Outreach. So
thank you so much, Lucinda.
Something great.
All right, Igor, we'll close it off now.
Yeah.
Oh man, that was a roller coaster, huh? Okay.
No, that was really good. I thought I was really scared that Perseverance, something would happen, and then we would be all miserable or depressed.
But it did.
This way, this turned out perfect. All the guests.
The great thing about this now is, there's the excitement that it landed, but then it builds on that excitement. There's so much more now that we get to look forward to. There's the helicopter. There's seeing what happens with Moxie, and creating oxygen in situ on Mars. Searching for life, that's going to be really big. So, so much more to celebrate. I'm going to go celebrate now. But really quickly, just want to do a huge thanks and a huge shout out first to the Mars Society. they're an amazing organization that really is purely dedicated to educating the public on putting people on Mars. There's so much work being done all across the world to make that happen. And they're there, you know, with simulation posts, with educational material, with these types of live events and watch parties. And so we, Igor and I, wouldn't be here without the Mars Society. So first of all, huge thank you to the Mars Society. I also wanted to do just a real quick personal thank you to James Burke within the Mars Society for helping us to get this live stream going. You know, we wouldn't be here talking to you right now if it weren't for James. So he's really kind of responsible for all of this, actually. So thank you again, James. Really appreciate it. Who else? Dr. Zubrin. Yeah.
I would also like, once again, to thank Lucinda
Yes,
for kind of teaching us the works with this Zoom and YouTube, and how do we get that done. You know, she was really there for us. She was supporting us all the way during this live. So thank you, Lucinda. It was,
believe it or not, we actually had no idea what we were doing about
this is our first.
So.
We also need to thank, and you know, rightfully so, Mike Stoltz for promoting us, for doing a really good campaign on all social media and in the newsletters. So yeah, thank you, Mike. Really appreciate it, and we're looking also forward to the future of MarsTalk.
And thank you to Dr. McKay. You know, I feel like we only got like 5 minutes to talk to him, and I know we wanted to talk for a little bit longer, but he made the time to walk us through kind of some of what we're looking for signs of life on Mars.
Yeah, I think he got all the points, you know, there. You know,
yeah, he did.
Yeah,
he made time for us too, which
you know, our guests are really busy people, so we're lucky to have them even for a longer and for a shorter time. So they just did us a favor.
And Igor, you know what? Thank you, Igor. Thank you for being a great MarsTalk co-host.
And thank you, Joe, for being also a great MarsTalk.
If there's anything I took away from this, it's that it's not pronounced Jezero. It's pronounced Jezero.
So now you know. Yeah, it's a good thing that I
didn't know. Now you know.
Yeah, it's a good thing that I'm from where I'm from. Yeah, you learn something every day.
Yeah.
You're gonna educate everybody in that way.
All right. Well, until next time, this is MarsTalk signing off.
And remember,
thank you
guys, always stay curious.
Always stay curious.
Bye.
All right. I ended the live stream, so we're good.